Okay. Good afternoon. I'm Yixuan from Ghent University, and my study is Perspectives of Experts on New Food Technologies, a Systematic Review. And first, for the background, as we all know, the technological revolution happened in the agri-food sector has greatly improved the productivity and the quality of food products. However, there is never a lack of hot debates on the adoption of new food technologies. And when it comes to this topic, experts are given very important roles as they have specific knowledge, professional experience, and their interactions with other stakeholders like consumers and farmers. Scientists are performed not only as the policy advisors, but also the most trusted group of public. Agriculture professionals and dietitians are the main information sources for farmers and consumers. Hence, experts' opinion will influence other stakeholders' decision on new food technologies. And for experts community, from the previous study, we can see experts community as a whole has a general positive attitude to new food technologies, but their attitude is not indiscriminately positive over all the aspects of new food technologies, and their perceptions of various risks and benefits are also different. Same time, within the expert community, we can see there is still conflicting opinions remain here. And the drivers of experts' evaluations are still not clear, according to the previous study. Here comes this study. This systematic review aims to comprehensively summarize previous expert studies to understand experts' evaluations of new food technology and what drives their evaluations. And we have 3 research questions on experts' perspectives, drivers, and methods and theories used in previous study. To our knowledge, this is the first systematic review of experts' perspectives on new food technology. And we use the SPICE model to build the eligibility criteria for selecting the qualified papers. It is composed of 4 important elements. First, for the settings, we only choose studies in the field of agri-food. And for the participants, which is the experts, as there is no clear definition of experts according to previous study, so we define experts as people who have acquired relevant knowledge through scientific or vocational training with an occupational characteristic as the intermediate between new food technologies and main stakeholders such as consumers and farmers. And here comes 2 types of experts included in our study. First, the scientific experts are scientists from all disciplines working in different institutions. And second type are the practitioners. They are applied experts in agri-food sectors such as dietitians and agricultural professionals. And for the elements interventions, which is new food technologies, they are mainly agriculture, biotechnology, nanotechnology, and new food processing techniques. And we only choose the studies which investigating the perceptions and behavior or intention or behaviors of experts. Based on this eligibility criteria, we build the search syntax which will be applied to databases to search for the qualified papers. And we employed 4 databases: Web of Science, Scopus, Google Scholar, and Google Customer Searches for the great literature such as NGO working papers and government reports. The field tags were applied in Web of Science and Scopus to eliminate excessive unqualified papers. And for Google Scholar and Google Customer Searches, we only extract a certain number of studies. For the tools, we use EndNote and Excel to manage and analyze the data we got. And the protocol of this systematic review has been registered on OSF. And for the screening process, after we got all of the papers searched from the databases, we still need the second screening process to determine which study we want to include in my study. So this is the inclusion criteria I used for the systematic review. We only include studies of which experts are the primary or part of the respondents, and their perspectives must be reported independently. And only the studies focus on experts' subjective evaluations published on scientific journals and use the primary data published in English or Chinese will be included in this systematic review. As you can see, at first we use the searching syntax and got like over 11,000 papers. But after screening using the inclusion criteria we mentioned before, we got 97 papers included in the final data analysis. Here are the general findings of my study. We can see most of the studies are focused on GM technology or general biotechnology and nanotechnology. To answer the third research question, which is the methods and the theories used in previous study, we can see that most of the studies included quantitative research. And the most common research method is structured and semi-structured interview. The most common data analysis method is descriptive analysis. For the series, there is only 7% of studies have theoretical support, which means not a lot of studies use theories to justify their research. And for the samples, which is experts, we give an overview of the expert sample, which included in the studies. Most of the studies are focused on scientists, and the sample size is ranging from 9 to over 1,000, and they are from different disciplines, different affiliations, such as university, research institutes, and so on. And some of the experts are working directly on the new food technology, and also some studies doesn't really have clear requirements on the work relevance of experts. As you can see in the scientist sample, most of the respondents are male scientists. And for the practitioner sample, we can see most of them are from agricultural professionals, extension officers, nutritionists, and health professionals. These are the general sample characteristics they used in the studies. To answer the first question, which is what is experts' perspectives on new food technology? As different studies are using different dependent variables and different outcomes, we categorize them into 4 types. They are attitudes, benefits or risk perceptions, behavior or behavior intention, and perceived barriers of adoption. First, we can say that experts as a whole has a positive attitude to new food technology. We can see a high support rate among experts on new food technology. But there are also other studies indicate that for the food application of certain technologies like biotechnology and nanotechnology, experts think these technologies as least beneficial or high risk. And for the attitude of different forms of adoption, we can see experts' attitudes are also different. We can see a high support rate on the developing or adopting new food technologies, while less support is accepting new food products. Well, the least support was done on the large-scale cultivation, which means according to previous study, we can say experts are not very positive to the large-scale cultivation of GM crops. And for the regulation, scientists also have different opinions, but we can say they highly support on regulating new food technologies. But for labeling, which is one of the important forms of regulation, experts' opinion are also different. There are some studies indicate that experts highly support for labeling, while other studies indicate that experts against the mandatory labeling or perceive as necessary to label products. More specifically, we can say a higher support rate for regulating commercial research than academic research. And for the benefits and risk perceptions, we use the ranking for different types of benefits and risks. For benefits, we can say a highly agreement on the benefits which will which will lead to the economic or technological improvement. But for the social welfare benefits, scientists are not very positive on this aspects of benefits. Well, for the risk perceptions, we can see that environmental risks was highly concerned by the experts. But here we want to focus on the social welfare. Like most of the scientists are concerned about the risks from the technological monopoly of multinational corporations, reducing farmers' welfare, and equal distribution of benefits, the rich-poor gap between social classes and all the countries, and so on. And for the behavior intention of experts, we can see a low or a negative attitude to consume certain new food products. And also some studies indicate that experts are unable or unwilling to recommend the new food products. Also for the perceived barriers for adoption, experts are perceived barriers from technological, economical, like public, cultural, and regulatory political factors, which from this kind of aspects of the barriers, which will prevent stakeholders from adopting the new food technologies. To answer the second research question, which is what drives experts' evaluations of new food technologies, we created this frequency table, which shows what kind of factors will influence experts' evaluations according to previous study. We can see the perceived benefits and risk and knowledge have a significant impact on influencing experts' evaluations, and also some socio-demographic factors like age, educational level, and other factors like social trust, religious belief also have impacts on experts' evaluations of new food technology. And here we also want to focus on the professional characteristics of like the disciplines, affiliations. These professional characteristics also have very significant influence on experts' evaluations. But how do these professional characteristics will influence experts' evaluations of new food technology? As for disciplines, we can say like experts from certain disciplines like biology, agriculture, they hold a more positive evaluations compared with experts from ecology or social science. For the affiliations, the experts from the industry generally hold a more positive evaluations to new good technologies. While for the experts from NGOs, most of them hold a negative attitude to the new food technology. For the funding scheme, we can say that experts who are funded by the government or public sector, they tend to have more negative evaluations to new food technologies. Well, for the experts from industry or the private sector, they are more inclined to have more positive evaluations on new food technology. Also, the professional titles also have impact on experts' evaluations. They associate professor and full professor have a more positive evaluations on new food technologies. Also, the work content for the experts who work directly in a certain area, work directly with the new food technologies and highly involved in the new food technologies, they tend to be more positive to new food technologies. And also their role in the new food technology, like the experts who develop new food technology will have a more positive evaluations, while the experts who do more on the regulatory or the risk assessment are more tend to be negative on the evaluations of new food technologies. To conclude, we can say that experts' attitudes were not monotonous, especially to some different aspects of new food technologies, such as different forms of adoption and different forms of regulations, such as labeling. Experts' attitudes are different. They are not like general positive to all the aspects of new food technologies. And also, for what drives experts' evaluations, we can see that professional characteristics is absolutely a significant factor which will highly influence experts' evaluations on new food technologies, such as experts from different disciplines, from different affiliations, funded by different sectors, will have different opinion on the new food technologies. And we can see some weakness still remain in existing literature. First, most of the studies are just to use single indicators such as a general attitude to evaluate experts' perspectives. And also they use some inconsistent measurements, not very scientific measurements to measure experts' evaluations. And also there is no clear definition of experts according to previous study. And you can see also there is not a lot of study employed theories to justify their studies. So there is still a lack of theoretical support among the studies. And also you can see a limited number of studies on experts compared with consumer studies and farmer studies, other stakeholder studies. So here we have some implications for future study, and which we can see we should it's necessary to have more studies, especially from different aspects, to do to evaluate experts' perspectives on new food technologies, and the scientific method and measurements, also the appropriate theories should be developed developed and used in relevant studies. Also, we can see a potential to make a comparison of the attitudes of different types of experts, such as experts from different disciplines, different affiliations, and have different roles in the new food or in the chain management. And we can also dig deeper into the relationship between experts' attitude and their willingness to recommend in this topic in the new food technologies. And for the practical implications, we can see there is still a need to communicate within the scientific community for the scientists from different disciplines, from affiliations. We see a need to communicate each other to reach to a common ground within the scientific community. But we can also see that out of the scientific community, experts are also playing a mediating role in scientific communication among stakeholders. So which is also means experts should take the responsibility and should know their own role in the scientific communication when they communicate with other stakeholders such as consumers and farmers. Yeah, that's my presentation. Thanks and welcome for any comments and questions. Yeah.
Thank you, Yixuan. Are you hearing me now?
Yeah.
Yes. apologies, we had a technical hitch, but thank you for getting on with it. We'll move straight to my presentation and do the questions after. Let's see if this works now. Are you getting that on the screen?
Yeah.
Okay, great. Just for anyone who is in the audience who does or doesn't know me, I'm an agricultural economist with PG Economics, based in the UK. And I've been looking at the impact of new technology like crop biotech now for nearly 25 years, and also looked at not only the impacts at the farm level, but some of the trade implications. And the information I want to talk to you about today relates to a study I was involved in doing last year for that was funded by the United States Soybean Export Council, which looked at the economic impact of Turkey's biosafety regulations. What I mean by biosafety regulations, I mean the regulations which govern the importation and use of commodities that may contain GM traits. Turkey introduced these regulations back in 2009, and I was involved in doing a piece of work 2 years after the introduction of that work to look at the impact then. And this is a study that goes back and revisits it some 10 years later. Now I'm putting up here, so you might say it's a strange way to do it, but I'm putting you here the summary of the report findings, and then I'll go through it in more details. But essentially, what we're talking about is the impact of the regulations on trade has been a significant trade diversion away from American origin feed ingredients like soybeans, corn, and derivatives, increased use of non-GM sources of supply, and a significant financial burden on the Turkish agri-food sector equal to between $1.5 and $2 billion US over that 10-year period, and an ongoing minimum annual cost between 107 and 133 million per year, but it's also likely to be higher than that. And a loss of income and employment generation in the economy of at least $500 million due to the closure of processing and trading facilities in Turkey and the siting of new investments in other countries. Now, the study focus was to do an independent assessment of the impact on sourcing and use of raw materials. It focused on the importing, crushing sectors, animal feed, food manufacturing, livestock production, and aquaculture. The main source of information came from a combination of desk research and a survey of representatives of companies and organizations in the supply chain. We interviewed, well, I didn't, but Siri interviewed 25 organizations. Whilst that is a small number, they were nevertheless the organizations that account for the vast majority of the importation, use and processing of the main soybean and corn derivative product use. You can see that we interviewed the players who are responsible for 70% of all soybean and soya meal and oil importation and use, 40% of total corn use, and about 50% of corn and cereal derivative use. So I think we've got a fairly good perspective of what is really, or what has really been going on in the supply chain in Turkey. Now, the way the biosafety regulation issues are affecting businesses is you have to start from some understanding of how the regulations have been set up and how they impact on trade. There is a zero tolerance policy for the low-level presence of unapproved GMOs in non-feed uses. So in other words, if you import any soybeans or soybean derivatives and you want to use them in the food use sector, there is zero tolerance. You cannot have any GM presence in your raw materials. And there is a 0.1 threshold for events that have been unapproved or awaiting assessment for feed use. Now, anyone who knows anything about this issue knows that it is impossible to guarantee zero presence of unapproved GMOs. Testing technology, for example, can detect dust and soil-borne microorganisms. You also have the fact that the Turkey regulatory approval system operates very slowly, and it's slower, much slower than the approval process for planting and exportation of many GMOs in the main GMO producing countries for soybeans and corn, like the US, Canada, Argentina, and Brazil. And the Turkish regulatory system, believe it or not, is even slower than the EU's. Interestingly, no GMOs have ever been approved for use in the food or industrial use sectors in Turkey. They're only approved for use in the feed sector. And approval has only been given for a limited number of corn and soybean events. There have been no approvals for events containing canola, cotton, or sugar beet. The trade diversion effects that the industry reported to us are that GMO sources of supply, not surprisingly, continue to be the main origins for use in Turkey. Well, I say not surprising because 95% of all trade in soybeans and soya meal comes from exporters who are predominantly GMO producers. But there has been a move away from the United States and Argentina, and there was, when we did this work, some use of non-GM sources, primarily Ukraine and Russia. I'll come on to more about that at the end. And in relation to soya oil use, there's been major diversion away from soya oil from GMO countries initially, and then soya oil has been largely replaced by sunflower oil. In the corn sector, you've seen significant trade diversion away from GMO producers, most notably the United States, in relation to the use of corn, corn oil, gluten feed, and dried distillers grain. In relation to the other crops, there's been complete diversion away from GMO producing countries for trade in cotton derivatives and canola. The key trigger dates that have caused problems in the Turkish supply chain came in the first 2 years after the introduction of the original regulations. Then you had another problematic time in 2013 with unapproved GMO events increasingly being found in corn imports. This was a time when you had a lot of new GMO events being approved in the United States, especially, which were not approved or hadn't gone through the approval process in Turkey. Again in 2017-18, when you had 3 very large boatloads of soybeans from the United States, 50,000 tons of soybeans in each case, turning up at Turkish ports, being tested and found to contain unapproved GMOs. You had this causing problems for the Turkish importation and using sector. And late in 2020 and early of last year, approval of GMO events widely used in soybean production, such as the very first herbicide-tolerant soybean trait that had been in use in most of the world, especially in South America and initially in North America from 1996. Its approval reached the end of its 10-year expiry in January 2021. So a lot of the Turkish supply chain anticipated problems in 2020 that would arise during that period. On the basis of the information we got from the industry, this table gives you an overview of the different categories of cost that they've been subjected to. Interestingly, over that 10-year period, the various industries have spent between 160 and $275 million just on testing. You've had various other costs. I'm not going to go through all of these during this presentation. You've had short-term impacts of price rises causing problems initially, again in 2017. For example, when you had those soybean boats in 2007 being rejected, the people who were going to, the companies that were going to use it then had to work out, had to pay charges to dispose of them outside Turkey, source alternatives, and at short notice you end up paying higher prices. There's been increased stock holding because they've had to move how they source and supply soybeans. And you've had, in some cases, additional costs of dealing with poorer quality and alternative supplies, such as moving away from using US origin and using Russian and Ukrainian sources. Many of the companies have had to employ additional staff to deal with the paperwork and testing. And there's been lots of problems with legal costs and fines and product recalls. And back in the early days, there was an initial problem with no approvals in the first year and the needing to divert to alternative supplies of corn, and that pushed up the domestic price of corn at the time. For the food industry, these are the estimates of the costs that have been imposed. You will recall from the earlier slide, I said there are no approvals for the use of soya or corn oil in food uses. So essentially, the industries had to divert to using sunflower oil. And most of the time during that 10-year period, sunflower oil has been more expensive than soy, and that's what it's cost them. Similarly, replacement of US origin corn oil and the certification of non-GM status, another $69 million. Traders also lose flexibility in the origins they use of moving between US origin when the US harvest is available later in the calendar year to Southern Hemisphere. In the early part of the year, they lose the flexibility of being able to source US origin because they basically have stopped using US origin corn because of concerns that there may be unapproved traits in any US grain they import. You've had replacement of soy derivatives in food uses. And in the early years of the regulations, the Turkish poultry and egg sector basically couldn't access soy meal and oil. So they had to use alternatives, which led to major costs associated with lower feed conversion and higher mortality rates in their flocks. The outlook we estimated that the annual ongoing cost of the regulations was between 107 and 133 million. But with a slow approvals process and many new GMO events being used and becoming to the market in countries like the United States, it is reasonable to expect more trade disruption and breaks in the raw material supplies and further crises affecting the supplies into Turkey. And those figures above of 107 to 133 million are, in my view, a minimum annual extra cost. So what are the deficiencies in the GMO regulations in Turkey? You have the protocols for testing are not published and are inconsistent. You get test results from different laboratories. So that adds to business uncertainty and risk. There are no GMO approvals for food and industrial uses. Couple that with zero tolerance thresholds for the presence of unapproved GMOs, you've got more complications and risk to traders. No approvals for oilseed rape, canola, sugar beet, and cotton. Again, another complication. And you've got a consistently slower approval process than other countries with import regulations. You also have liability provisions which lack clarity, which means business owners often face fines and even jail even if they've taken reasonable care to avoid importing and using unapproved GMOs, just because a lab produces a positive test. So as I said in the opening slide, the total cost burden we estimate at between 1.5 and 2 billion US dollars. That's added cost to the Turkish supply chain and must have been passed on ultimately through the supply chain to feed users and to the price of meat products and livestock products that the Turkish industry sells both domestically and on world markets. And we also estimated that there had been a loss of income and employment generation in Turkey of at least 500 million. That basically reflects the fact that a couple of the traders and importers told us they basically shut down their processing facilities in Turkey and moved them to other countries, such as the Ukraine. Addressing the deficiencies. If Turkey is to improve its regulatory environment and minimize the cost to its industry, it basically needs to operate a science-based approval system in which the procedures for assessment and data requirements are transparent. They need to be timely and clear deadlines for completing the assessment process. And very importantly, the organisation with this responsibility needs to actually have sufficient numbers of suitably qualified staff. There's also a need to clarify and amend the liability provisions in the regulations to remove the risk and uncertainty, the stress and the cost that importers face. And there's also a need to introduce workable thresholds for the presence of unapproved GMOs, because zero tolerance threshold is undeliverable in any commodity system. It's also inconsistent and unworkable to operate zero tolerance threshold at all. It is interesting to note in stating these issues of deficiencies that ironically many of the supply chain in industry said it would be better if Turkey adopted the same regime of approvals that operates in the EU. And that is against the background of the fact that the EU's regulatory system for importation and use is grossly dysfunctional, slow, and not fit for purpose. And I'm not the only person who says that. Even the European Commission agrees with that, and the European Court of Auditors. One of the points I did raise in there was how Turkey, how the supply chain in Turkey had moved some of its purchasing of raw materials to avoid the risk of unapproved GMOs being found in supplies, and taking up supplies from countries that predominantly produce non-GM soya, namely Russia and the Ukraine. Well, as we all know, this has caused problems in the last few months. And during the last few days, I asked my contacts in Turkey how they were dealing with this. And they said, basically, they're not importing anything from Turkey and Russia because they can't get any. Bearing in mind that Turkey has not chosen to not import from Russia. And the alternative sources of supply that the Turkish processing sector has taken up is they basically bought more from Argentina and Brazil. So they've gone back to using GM raw materials and avoided the US because of the risk that there's more risk of unapproved events being in US supplies than there are in South American, but not totally. Anyway, on that note, I'll stop my presentation, stop sharing.